Hello students, let us continue chapter 10, Light, Reflection and Refraction. So students, today we are going to discuss our next topic, sign convention for reflection by spherical mirrors. So while dealing with the reflection of light by spherical mirrors, we shall follow a set of sign conventions known as the new Cartesian sign convention system. In this convention, the pole P of the mirror is taken as the origin 0, 0. Then the principal axis of the mirror is taken as the x-axis, or we can say x dash of the coordinate system. And so the conventions are as follows. Let us discuss. Very first, the object is always placed to the left of the mirror. Remember, the object should be in the left side. This implies that the light from the object falls on the mirror from the left hand side. Now, all distances parallel to the principal axis are measured from the pole of the mirror, that is from origin. Along with that, all the distances measured to the right of the origin, that is along plus x-axis, are taken as positive, while those measured to the left of the origin, that is along minus x-axis, are taken as negative. Also, distances measured perpendicular to and above the principal axis, it means along plus y-axis, are taken as positive, while distances measured perpendicular to and below the principal axis, it means along minus y-axis, are taken as negative. So, these sign conventions are applied to obtain the mirror formula and solve related numerical problems. Next topic, mirror formula and magnification. So, let us start with mirror formula. In a spherical mirror, the distance of the object from its pole is called as the object distance, denoted by small u, while the distance of the image from the pole of the mirror is called as image distance, denoted by v. And we know that pole is the origin. Then also we know that the distance of the principal focus from the pole is known as focal length, denoted by small f. We have already discussed in last videos. But there is a relationship between these three quantities given by the formula known as mirror formula. And the expression is 1 upon v plus 1 upon u is equal to 1 upon f. Here, this formula is valid in all situations for all spherical mirrors, for all positions of the object. Next, magnification. Magnification produced by a spherical mirror gives the relative extent, the expansion to which the image of an object is magnified with respect to the original object size. The ratio of the height of the image to the height of the object is known as magnification. This is the actual formula. It is usually represented by the letter small m. If h is the height of the object and h dash is the height of the image, then the magnification m produced by a spherical mirror is given by m is equal to height of the image, that is h dash, upon height of the object h. The magnification m is also related to the object distance u and image distance v. It can be expressed as m is equal to minus v upon u. As the object is usually placed above the principal axis, the height h of the object measured upwards is taken to be positive. And the height of the image should be taken as positive for virtual images always, while it is to be taken as negative for real images. A negative sign in the value of the magnification indicates that the image is real, while a positive sign in the value of the magnification indicates that the image is virtual. Now, some textual and in-text numerical questions. So let us start. Example 10.1. A convex mirror used for rear view of an automobile, that means side glass of an automobile, has a radius of curvature 3.00 meters, that is 3 meter. If a bus is located at 5.00 meter, or we can say 5 meter from this mirror, find the position, nature and size of the image. Let us start the solution. As it is a convex mirror, so we know that radius of the curvature is given r is equal to plus 3.00 meter. And object distance, according to the sign convention, we know that object should be placed always in the negative Cartesian system, negative place. So u will be equal to minus 5 meter. We have to find out image distance v and height of the distance h dash. We know that in case of convex mirror, image is always virtual, erect and behind the mirror. That's why here the radius of curvature will be plus 3 as it is beyond the mirror, backside of the mirror. So object will be negative according to our sign convention, and hence let us start the focal length. Focal length, we know that it is the distance between pole and principal focus, denoted by small f, and it is half of the radius. So 3 upon 2, f is equal to r upon 2, that is 3.00 upon 2, which is equal to plus 1.5 meter. And our formula is 1 upon v plus 1 upon u is equal to 1 upon f. Or we can take 1 upon v is equal to 1 upon f minus 1 upon u, because we know the values of f and u. Here 1 upon 1.50 will be equal to focal length, and minus 1 upon minus 5.00 will be equal to u, object distance. So we can write 1 upon 1.50 plus 1 upon 5.00, because minus into minus will be plus. And hence we will have the answer 5 plus 1.50 upon 7.50. Hence 1 upon v is equal to 6.50 upon 7.50 on taking LCM. And its reciprocal, which will be equal to v is equal to 7.50 upon 6.50. And hence the answer is 1.15 meter. So the image is 1.15 meter at the back of the mirror. Here the value of v is plus 1.15 meter. That means the image will form on the positive side of the Cartesian system, positive side of the pole, plus axis. And hence we can say it will be back of the mirror. Now magnification, m is equal to h dash upon h, that is height of the image upon height of the object, or minus v upon u will be equal to minus 1.15 meter upon minus 5.00 meter. Minus and minus will cancel out and answer will be plus 0.23. So we can say the image is virtual, erect and smaller in size by the factor of 0.23 as it is convex. Next, example 10.2. An object 4.0 centimeter in size is placed at 25.0 centimeter in front of a concave mirror of focal length 15.0 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Also find the nature and size of the image. So let us start. Here the object size is given. Object size, that means height of the object, will be equal to 4.0 centimeter, while it is placed at 25 centimeter in front of a concave mirror, and we know that according to the sign convention u, that means object distance object should be always in the negative side of the pole. So object distance will be minus 25.0 centimeter, negative side of the pole. Again, focal length, we know that focal length is what? It is the distance between pole and the principal focus. In case of concave mirror, the focal length will be negative, because here the object and image both are in the same side of the mirror, that is in negative side. Now we have to find out image distance, that is v, image size, that is h dash. Now let us start our equation number 1. 1 upon v plus 1 upon u is equal to 1 upon f. Or we can write 1 upon v is equal to 1 upon f minus 1 upon u, because we know the values of focal length and object distance. So we can write in place of 1 upon f, 1 upon minus 15.0, while in case of 1 upon u, it will be minus of 1 upon minus 25.0. So we can write minus 1 upon 15.0 plus 1 upon 25, because minus into minus will be plus 25. So we can write 1 upon v is equal to, on taking LCM, minus 5.0 plus 3.0 upon 75.0 will be equal to minus 2.0 upon 75. Or v, this is 1 upon v, and on taking reciprocal, we'll write v is equal to minus 37.5 centimeter. So the screen should be placed at 37.5 centimeter in front of the mirror. Hence the image will be real definitely. Also magnification, h dash upon h or minus v upon u will be equal to h dash is equal to vh upon u. As we have to find out h dash only, that's why we'll write minus vh upon u. So put the values, v will be equal to minus 37.5 into h is 4.0 divided by u minus 25.0. So on solving, minus of minus 37.5 into 4 will be equal to minus of minus 150 divided by minus 25. And minus 150 upon minus 25 will be 6, and hence minus 6.0 will be our h dash, and hence image is inverted and enlarged. Next, in text numerical questions, find the focal length of a convex mirror whose radius of curvature is 32 centimeter. We know that there is a relation between focal length and radius of curvature. Focal length is half of the radius, so it is very easy to solve. The radius of curvature is given 32 centimeter. So we'll write f is equal to r upon 2. Hence 32 upon 2, and 16 centimeter will be the focal length of convex mirror, which is always positive. As the image is obtained behind the mirror, that is on the positive side of the pole in the Cartesian system. So answer is positive. Last numerical, a concave mirror produces 3 times magnified real image of an object placed at 10 centimeter in front of it. Where is the image located? So let us start. Here magnification m will be equal to minus 3, because they have already declared about real image, and real image shows negative sign always because it is inverted. Again the object distance u will be minus 10 centimeter. According to sign convention, object distance should be always negative side of the pole. And we will have to find out magnification. M is equal to minus v upon u, or v is equal to minus m into u. That is minus of minus 3 into minus 10. But minus 3 into minus 10 will be equal to 30, and hence v will be minus 30 centimeter. So the real image is located at 30 centimeter in front of the mirror on the same side of the object, as it is a concave mirror. So students, I hope you understood this topic. In next video we will discuss about the refraction in slab and refractive index. Thank you for listening.